All right, we're going to be talking about the order of operations here and going over a few examples. But before I actually jump into those examples, just want to go over a couple important things. First and foremost, the actual importance of this concept. When we're dealing with the order of operations, it's essential to almost all of mathematics due to the fact that it underlies everything. Without the order of operations, we wouldn't know what order to take, what we were doing. It would be like driving around your car and not knowing if you should go on green, yellow, or red. It would be complete chaos. And mathematically, the result of that would be everybody would be getting a completely different answer. Imagine that with engineers out there building bridges if one person thought one thing and one person thought something else. The other thing, when we think of when we think of the order of operations, we think of PEMDAS, right? P, E, M, D, A, and S. Okay, think of that as being a very key concept here. But one thing to really remember with PEMDAS, and it's where the common mistakes lie, is that it's not to be taken literally. Yes, you do parentheses for the P before you do E, which is the exponents. But there's a misconception that you always do multiplication before division and that you always do addition before subtraction. But that's not always the case. We need to think of the fact that multiplication and division are like on the same level. The same thing with addition and subtraction. They're on the same level. It's not that one always comes before the other one. We could almost think of them as the same thing. If you multiply by 1/2 or you divide by 2, you're doing the same thing, right? And if you take the number 8 and we multiply that by 1/2, we're going to get 4, okay? If we take the number 8 and we divide it by 2, we're going to also get the number 4. So we're dealing with a situation where it's basically the same operation. So what you need to do in that situation is you need to work from left to right. So if you have a problem where there's multiplication and division, work from left to right, just like you read. Okay? So thinking about those two things, you got to keep those in the top of your head. But let's jump into a couple examples here. All right. So first one, just kind of utilizing a few of the different operations here. Let's say we had something like 2 squared, and I'll keep it in the top corner here, the PEMDAS, so we can remember it. All right, we got that there. Just to look back to reference, and so say we have 2 squared plus the quantity, in parentheses here, 3 plus 4, make that plus a little better, minus 6 times 1. Okay, and one really key thing that I want to demonstrate here when you're going over this kind of example is to, well, first and foremost, follow the order of operations, but when you're doing that, to rewrite each time. One of the most common mistakes with order of operations is just making a silly little addition or subtraction error because we rushed things. We got too confident, we did things too quickly. So looking at this one here, first things first, parentheses. So we have the 3 plus 4. Instead of just doing that in my head and let's not write anything else down, what I'm going to do is I'm going to rewrite this problem. I'm going to change that 3 plus 4 to a 7, and then I'm going to rewrite it. So here we have 2 squared plus 7 minus 6 times 1. Okay. From there, we have exponents are going to be next, so 2 squared equals 4. And again, I'm going to rewrite this problem. Okay, don't two things in your head. Don't get overconfident on problems like this. It's really easy to do, and I've seen students of all levels have trouble with that. Next thing, we have addition, subtraction, and multiplication. Again, following the order of operations, we're going to do the multiplication first. 6 times 1 is 6, so I'm going to rewrite just below that 6. Rewrite the whole problem, 4 plus 7 minus 6. And now we have addition and subtraction, which are essentially the same, but we're going to work from left to right. So we do the 4 plus 7, which gives us 11, minus 6, and 11 minus 6 is 5, which is our final answer. Okay? And if we kind of think about it, it's almost like an upside down triangle here that we're working. If we wanted to draw that out, we start out really big, and then we get smaller and smaller as we simplify things. Okay? So think of it like that and really rewrite the steps each time, each step separately, just because it's really easy to make little mistakes on it. Okay? So let's look at a different one here. So that was kind of our standard one where we had a little bit of everything. But what about some of those easy areas to make mistakes, or those kind of trick ones? Like I was mentioning, if you have one where you have division, okay, say 8 divided by 2 plus 4 times 5. A common mistake here is to multiply 4 times 5 because we think that that M always comes before D in PEMDAS, but it's really that M and D are part of the same level, okay? They're the same thing. And so we work from left to right. So we look at the division is actually to the left of the multiplication. We do that first, which 8 divided by 2 is 4. We're going to rewrite it just like I was talking about. 4 plus 4 times 5. Now we have addition and multiplication. We do the multiplication first, giving us 20. Then we have 4 plus 20. Final answer of 24. Okay? All right. Now, final one here that's something a little bit different to look for is when we talk about parentheses, another option is brackets. And brackets and parentheses are really the same thing. So we could even alter the name PEMDAS further to make sure we included those. But for now, we'll just look at it and say P is the start of our PEMDAS. But that could mean parentheses like this. It also could mean brackets like that. And why we might actually use brackets is a situation where if you have both in the same problem, and just so you don't confuse things, you don't know where one parenthesis starts and one parenthesis ends, if we use brackets and parentheses, it just kind of is easier for us to distinguish things. So if we had this problem here where we had, say, brackets on the outside, and then inside those brackets we had parentheses, something like 2 plus 3, end parenthesis, plus 6. Now we end the bracket. And see how we can tell where one starts and one begins. We know that the bracket starts right here and ends right there. There's no confusion that, oh, does it start here and end there? Or there's just nothing going on like that where we kind of are confused and don't know of what the situation is. This way we know exactly where one starts and one ends. So we have that bracket, that parenthesis, and then let's say on the outside we had minus 3. Okay? What we want to do here when you have parentheses and brackets is we're going to work from the inside out. In this case, we have the parenthesis on the inside of the bracket, so we're going to do that first, which gives us 2 plus 3 equaling 5. Now we're going to rewrite it again. Bracket 5 plus 6, bracket minus 3. We're going to do what's inside the brackets now, following the order of operations. 5 plus 6 is 11 minus 3. 11 minus 3 is 8, and that is our final answer. So kind of in summary here, be really careful in the order of operations. It's very, very important. It underlies everything and makes sure that we all get the same answer and we're all on the same page. And really watch stuff in terms of brackets, parentheses, and even more so when you're dealing with multiplication and division, the same problem, and addition, subtraction. Remember to work from left to right. All right, good luck with it.